Hey scholars, I am so excited to be teaching you such a fun lesson. It is finding the area of circles, sectors, and segments of circles, but I want to do a quick review of all these formulas because all the formulas you learned for the last test is going to be used throughout the whole semester, so I want to do a quick review with you. The first one's the area of a parallelogram. Area of a parallelogram is just base times height. The area of a triangle is base times height over 2. Now, there is one for an equilateral triangle, but you have to memorize this one on your own. And that's side squared root 3 over 4. It's a huge time saver. Huge. Using calculus helps a little bit. Trapezoid's another big calculus one that you use. Its area is the sum of the bases times the height over 2. Now, remember for a kite or rhombus, the reason why they're on the same page is because they have perpendicular diagonals, okay? So, and it's the length of the whole diagonal. So the area of it is diagonal 1 times diagonal 2 all over 2. And then the area of a regular polygon, we had that is apothem times perimeter over 2. Now remember, P was the perimeter, A was the apothem. You first draw the central angle triangle. Just remember that. And I just want to draw one here to remind you what that meant. Those were the same, radius, radius, side length, apothem. And remember how the apothem would bisect the central angle, and remember there would be your central angle. You'd have to know the number of sides too. Circumference of a circle was 2 pi r, or pi times diameter. We use a capital C to represent that, and we had the length of an arc. The length of an arc is m over 360 times the circumference, or you could be more specific, m over 360 times 2 pi r is kind of the choice that I use with this one, but m is the degree measure of an arc. And remember, we have minor arcs, which are measure less than 180 degrees, major arcs, which is greater than 180, and semicircles, which equal 180. And the first formula that we have is just the area of a circle. And the area of a circle, remember the two most important things of a circle: the center for its location, and second of all, the length of the radius, because it tells me how far the points are away from the centers. So that makes the circle. And the area is just pi times the radius squared. Nothing really fancy. And yes, you're still going to be expected to write it down every single time. And we're also going to be writing it down in terms of pi. So area is going to be pi times the radius squared, but here I have the diameter. Well, remember the diameter is twice the radius. So you can literally go 11 equals 2r. The radius is 11 over 2. So when I plug it in, I get pi times 11 over 2 squared. When you square fractions, you square numerator and you square the denominator, okay? So that ends up being 121 over 4. And then we always put the pi last. Even though they always put it first, we always put it last. And we'll put it in the numerator. So that's 121 pi over 4. And this is area now, square centimeters. And then same type of idea for the next one, really simple. You will see me anytime I plug in radius, notice parentheses go around it. It's so when I have radicals or fractions, I don't forget to square things correctly. So I get pi times 7 squared, well that's 49 pi square centimeters. Now those of you who want to punch this into your calculator, do not. Terms of pi is kind of like the simplest radical form or simplest fraction form. Okay, we're going to head to the next page and do some more work.